Hi, I'm Jeff Cogswell. Today we're going to talk about barriers in OpenMP. So, what is a barrier? It's where all threads in a team that are running together get to a point where they wait for each other. Uh, for instance, have like 3 or 4 threads and they're working together and processing something, and there's a point where the threads all need to finish their task, and they'll reach this barrier and one by one wait for all the other threads. And once all the other threads are at that point, then they'll all continue on. Now, a barrier can be implied or implicit. If they're implied, for example, in a for loop, you don't actually explicitly state that there's a barrier at the end. Or you can code the barrier explicitly. And so why would you use it? Well, several threads need to work together to calculate a final number, for example. Or you might have several threads sending out data and requesting data. Then one or more threads might need the final calculation or the final set of data. Therefore, this thread must wait for the others to finish. So implicit barriers don't need any extra work. Like I mentioned earlier, if you're using a for loop, they're built right in. However, if you want to actually explicitly create a barrier, all you do is pragma OMP barrier. Then all threads in the team will wait for when they get to this point before continuing on. And now there are some cases where you might not want to use a barrier, such as in your for loop. In that case, just add the no wait construct. And yes, there is a cost to using these. You're going to get some overhead, some performance overhead, so you need to weigh whether you really need them or not. So how do they work? Well, I did some searching and I found this interesting GitHub repository where these guys put together a really interesting demonstration of how to actually implement barriers. Now, what they're talking about here is they're using OpenMP in this case, and they're assuming the barrier construct doesn't exist, and then they implement them manually. I encourage you to take a look at this. It's JEDIVIND barrier sync on GitHub. And if you go to the MP, you can see the different code. Here they do a centralized barrier, and they do 3 different types of barriers. This one's called centralized, and you can see they're actually using OpenMP, such as up here they've got pragma OMP critical, and so they're fully using OpenMP except OpenMP barrier. That part they're implementing themselves. Now you wouldn't actually implement this yourself, but this is an interesting exercise to see how they work under the hood. And they've got 3 different types: centralized, dissemination, and tournament. So that's it. There's not a lot of barriers, but they're pretty useful, and you may find a place for them, or you may find you don't want to use them, in which case you can use the no wait construct.